Chapter 6, Lesson 6, the distributive property. You will be able to use the distributive property to compute multiplication problems and to rewrite algebraic expressions. To multiply a sum by a number, multiply each addend by the number outside the parentheses. The expression 3 times the quantity 20 plus 15 and 3 times 20 plus 3 times 15 show how the distributive property combines addition and multiplication. So really what you have is you have a number on the outside of the parentheses and numbers inside the parentheses. You want to take that number on the outside, in this case 2, and distribute it to everything on the inside. And the way that we do that is through multiplication. So 2 times 7 plus 2 times 4. Okay? Now, sometimes it's easier to use the distributive property instead of multiplying mixed numbers. For example, we have 9 times 4 1/3. I don't know what that is, and I can absolutely do that, change this to an improper, and do the multiplication. However, using the distributive property, we can speed it up a little bit. For example, 9 would be the number we are multiplying, and we want to take 4 1/3 and break it apart. Well, 4 1/3 is the same as 4 plus 1/3. You have 4 wholes, and 1/3 is your part. So now we distribute the 9. 9 times 4 plus 9 times 1/3. Well, 9 times 4 is 36 plus 9 times 1/3, put it over 1, we get, I'll branch it off over here, we get 9 over 3, which equals 3. So 36 plus 3 is 39. Let's do it again with letter B. We have 5 plus 2 3/5. We can break 2 3/5 into 2 plus 3/5. So then we distribute the 5. 5 times 2 plus 5 times 3/5. Well, 5 times 2 is 10 plus 5 times 3/5, put that over 1, and we get 15 over 5, or just 3. So 10 over 3, or 10 plus 3, excuse me, is 13. Letter C, 12 times 2 plus 1/4. We have 12 times 2 plus 12 times 1/4. 12 times 2 is 24 plus, let's put this over 1. 12 over 1 times 1 over 4 is 12 over 4. And 12 over 4, fractions are division, is 3. And we get 27. We can do the same thing with decimals. 2 times 3 plus 0.6. Distribute 2 times 3 plus 2 times 0.6. I'm going to put this one in parentheses just to not confuse myself with decimals. I'll put this one in parentheses as well. 2 times 3 is 6 plus 2 times 0.6. Well, 2 times 6 is 12. 1 behind the decimal point, so 1.2. And 6 plus 1.2, remember, line up your decimals. 6.0 plus 1.2 is 7.2. Use the distributive property to rewrite each expression. We can also use it with variables. Now, inside the parentheses, I can't add x and 3. I don't know what x is, so I can't just arbitrarily add it to 3. So what I can do to get rid of those parentheses is distribute that 2. So 2 times x plus 2 times 3. 2 times x, I don't know what it is, so I can leave it as 2x plus 2 times 3 is 6. And we would leave it as an algebraic expression. We don't know what x is, so we can't find a numerical solution. Letter F, distribute the 8. So we get 8 times x plus 8 times 3. 8 times x, I don't know what that is, so 8x plus 8 times 3 is 24. I cannot add 8x and 24. I do not know what x is. I cannot add it to a normal number, a constant. Letter G, 5 times 9 plus 5 times x. We get 45 plus 5x. And notice how I'm going in order of the parentheses. This time I did my numbers first because the 9 was first. Go from left to right always. Letter H, 2 times x plus 2 times 4. We get 2x plus 8. Now, factoring an expression. When numeric or algebraic expressions are written as a product of their factors, the process is called factoring an expression. Factor each expression. So really what we're doing is we are doing the reverse of the distributive property. In order to do this, we need to know the factors of 12 and 8. The best way that I like to do it is to do some factor trees and keep your 12 on the left and your 8 on the right. So let's do some factor trees. 12 is 2 times 6, and 6 is 2 times 3. Bring down that 2 so it lines up. 8 is 4 times 2, and 4 is 2 times 2. Bring down the 2 so it lines up. Now circle what's in common. We're going to find the greatest common factor. We have a 2 in common and another 2 in common, which means our GCF is 4. So because our GCF is 4, that's going to go on the outside of the parentheses. On the inside is going to be what's remaining. Now remember I told you to keep the 12 on the left. Since 12 is on the left in this expression, it must remain on the left. And what's left over, let's pick a color, let's do green for this. What's left over is a 3. So bring that 3 down. And what's left over on the second part is an 8. So is a 2. So bring that 2 down. And I did addition here because I had addition in the original expression. So this is factoring the expression. Let's look at letter B. Again, let's do some factor trees. Keep 9 on the left. 9 is 3 times 3. 21 is 7 times 3. Looks like a 3 is in common, so the GCF equals 3. On the outside of the parentheses is a 3. Remaining on the 9 tree is a 3. Bring down that plus sign. And remaining on the 21 tree is a 7. So this is the factored expression. Letter C. 14 is 7 and 2. 28 is 7 and 4. And 4 breaks down to 2 and 2. Bring down the 7. It looks like we have a 7 in common and a 2 in common, which means 14 is our GCF. So 14 is on the outside of the parentheses. Now here, we have nothing left. But we actually do have something. There is an invisible 1. So when everything is gone, remember, 1 is also a factor of 14. So 1 would be remaining. Bring down the plus sign. On the 28 tree, we have a 2 remaining. Letter D, we have 80, which can be 10 and 8, 10, which is 5 and 2, 8, which is 4 and 2, 4, which is 2 and 2. Bring down the rest of the numbers. 56 is 7 and 8, 8 is 4 and 2, and 4 is 2 and 2. Bring down the 2, bring down the 7. Looks like we have 3 2's in common. So 2 times 2 times 2 is 8 for our GCF. So 8 is on the outside. Now we actually have 2 numbers remaining in the 80 tree, so what we need to do with that is multiply them. So 5 times 2 is 10. So 10 is remaining in the 80 tree, plus. In the 56 tree, we have a 7 remaining. So this is our factored form. Now factoring especially becomes useful when we have variable expressions or algebraic expressions. Well, 3x, the tree, remember it's just 3 times x. And 3 is a prime number, so that we're good there. 15 is 3 times 5. Our GCF is 3. So 3 is on the outside of the parentheses. It looks like on the first tree we have an x. On the second tree we have a 5 left. And bring down the plus sign. Letter F. 16 is 4 and 4. And each of these 4's has 2 2's. 4x is 4 times x. And 4 can be broken down to 2 and 2. Bring down that x. We have 2 2's in common here. So our GCF is 2 times 2, or 4, which goes outside the parentheses. And remaining on the first tree is 2 times 2, which is 4. And remaining on the second tree is just x. So 4 times the quantity 4 plus x.